Very well. Yeah, thank you so much for coming to my talk. Thank you for a lovely introduction, Michael. So I am Mario Havel. I am part of Ethereum Foundation's protocol support. We are a team with an EF which helps to facilitate the core development of Ethereum. And today I'd like to talk a little bit about that, about Ethereum development. And you might think at this conference, like, oh, this proof of stake fella coming here, it's just the danged Ethereum. If you haven't seen the Futurama episode, I really recommend it. It was all about mining. It was fun. So yeah, what am I even talking about here when there is no proof of work in place? Well, I want to talk a little about Ethereum development, about how we got to this point, how all this development actually is being done, coordinated a little, and what actually is Ethereum under the hood, and yeah, what changed since the merge, what happened, and what is going on. I don't want to really get into some discussions about proof of stake, proof of work nuances, because I come in friendly manner, and I find it in a way that, like, in reality, there are certain trade-offs to these technologies, and so we are past that. Like, Ethereum chose certain trade-offs with going on the proof-of-stake path, and I want to talk about how that went and how Ethereum is doing. And to understand the merge and the whole structure of Ethereum, first, I would like to talk about a little about what are the Ethereum development principles, where is it coming from? Because even with the proof of stake and all of these changes along the way, Ethereum still follows certain design, certain ideas established way in the back, and these principles are a reflection of some prehistory of these technologies, right? Coming from 70s, 80s, where the development of Unix took place, and Unix bringing this idea of, like, well, open development, the development where people actually share things. It was this atmosphere in 8080 labs, collaborating with, like, MIT researchers, and everybody had just opened their office, and everybody was working their own thing, but actually collaborating. And that's how Unix works, that we have a certain modularity, right? We have different pieces of software which do what they do best, and then just compose with each other. So that's beautiful. And of course, to make Ethereum work as well, any of the cryptocurrency here, it's free and open source software, and its specification, everything is open, building on legacy of cypherpunks, crypto-anarchists, and these things are kept in mind when we talk about the design principles of Ethereum. The goal for Ethereum is to be simple, universal, modular, not discriminate against anyone, and be agile. What does it mean? Well, simplicity means that the specification or the Ethereum itself should still be somewhat simple. Yeah, when it was written down in 2014 or so, 2015, it said, like, it should be implemented by a regular a regular programmer should be able to implement it. And I believe that it's still there because, well, the complexity is growing. So the proof of stake, after this transition, we introduced a lot of complexity to the ecosystem. But however, this is sort of encapsulated complexity. So there is this strategy of how Ethereum manages complexity, that it encapsulates it in this module that it's part of the modularity as well. So we have the proof of stake engine, the beacon chain, the execution client, which talk to each other over a simple API, the engine API, and this makes it easy to debug if there is a problem in one or the other. And the sandwich complexity is how Solidity works, how the contracts work. That we have some readable language, we have Solidity, which is auditable, then it goes through the complexity of compiler, and the bottom of the sandwich is the EVM 30-ish bytecodes, which are, again, verifiable, mathematically, formally verifiable, right? Ethereum in its design doesn't discriminate against any use, so it comes with this freedom and neutrality that the Ethereum is built in a way that it's not biased towards a single purpose, and it's very generalized. It's built as a low-level machine, and there are no like, you know, this is the token standard on Ethereum. It's given just by community, just by what community wants to build, not by the core devs. And the important part here is that Ethereum devs are not scared of risks, or like they're willing. The Ethereum community is willing to take a risk for a good payoff. So there is certain non-risk aversion. So if there is 10% risk for 90% payoff, it's worth it, not the other way. Yeah, history. We have Ethereum specified first in the yellow paper. It's beautiful, italic in Bitcoin keynote 2014, right? That's funny. There are EIPs, but all of this comes together to execution and consensus specs. So when we talk about Ethereum upgrades and development, there are basically versions of Ethereum which have certain code names. The latest one is Shanghai and Chapella, and these are updated in the specification. So we have these PI specs which are very well defining exactly how Ethereum should behave, and based on those we have 10 different implementations. So, and one of these upgrades exactly a year ago was the merge, the one which brought us the proof of stake. We counted down actually from here, from Prague, and as we reached this terminal total difficulty value, what happened was that we switched the consensus. So how the bit under the hood, just to give you the idea of why we call it the merge, why it's not split or the other way, because we are connecting the two networks, the beacon chain and the old proof of work networks. Before the merge, it looked like this, and what's happening here is that we have the validators attesting, creating the beacon blocks, each slot and proof of work. The old chain is doing its own thing, but at one point, instead of listening to miners, it becomes one piece, one block, which where the validators actually attest to the execution layer data. So that's why we call it the merge, because we merged two networks together. And since then, what happened was that, well, there were no major incidents. Nothing went horribly wrong. The network didn't went belly up. That's good. There were minor incidents. There were two periods where the network was not finalizing because of bugs in block productions in some clients, but the network recovered after a few hours. That doesn't mean that there were no new blocks produced. The slots were going on as the gas works. However, we didn't see finality for some time. The liquid staking derivatives are growing. That was something which we've been warned about, and we see it happening now, Lido being big and so on. So that's something that the community should be aware of, and it's something which is risk in the proof of stake world. Chapella happened, the withdrawals upgrade. It was upgrade in April this year, which brought many things, but the main upgrade was the withdrawals. So I would say actually finished the merge here. We actually finished the proof of stake transition where we enabled the full validator withdrawals. And of course, there is a bunch of more research based on this in progress. I'm going to talk about it. I wanted to show the chart of the inflation. So one of the things is that with the supply minted each slot is lower than with proof of work. So you see the difference between proof of work Ethereum and proof of stake Ethereum. So we save on inflation. And so how Ethereum looks right now under the hood, just to give you an idea what it is now, this beast. So we have the EVM as the heart, as the core of Ethereum, which receives transactions from some peer-to-peer layer, and this is executed in EVM and updates state of Ethereum. The state meaning that it's the current state, but also builds the whole state database and the history. But this used to be basically Ethereum plus miners, but now this is what we call the execution layer. This is what you normally talk to. This is what was the Ethereum client. You use your wallets, MetaMask, whatnot, connecting to this RPC. But then we have another RPC, another endpoint here, which is the engine API, because it drives the engine, and that's the consensus layer, which dictates the execution layer, what is the current head to sync to. So we have the fork choice run by LMD Ghost. And That's part of the beacon chain. Beacon node provides beacon APIs, which is meant for validators. So if you're interested in the beacon state, you can learn it from this CL client. So this is how the actual Ethereum is right now. It's merged. It's two networks instead of just one network. We have two which are slapped together, glued together, and one client is basically two pieces of software at this point. Each has its own peer-to-peer layer, so they're through different networks. So this is how it looks like, and you see there is certain complexity and certain new issues involved. So what is the research looks like now? So all this research and development happens out there in the public. Like this thing is not a conspiracy of few core devs out there. It's all discussed publicly, and you can follow it on the dev calls, which are every week. 1 week it's for execution layer. The second week is for consensus layer. On Thursday, it's 2 p.m. local time, 3 p.m. And for specific features like 4844 EOF or some testnets starting, all the EIPs are discussed at ETH Magicians, and a lot of important discussion goes on ETH Research or R&D Discord, where you can find a public invite. So yeah, all of these things which are happening around, whether it's proof of stake or Ethereum upgrades, are in this repository you can find overview of what's happening right now. You can find links to all of those calls, and anybody can join them. So what is this research? What is happening now? And I wanted to talk a bit about the proof of stake because, well, it introduces some things which enable us to build on it. And opens new features for Ethereum, but also we need some fixes. Also, there are some problems with it. So actually, with the proof of stake, there is a big part of it is generally optimizing it and upgrading it, because the beacon chain has been here since December 2020. The consensus network, and since then the technology would be considered today pretty old. So there are some client devs who would argue that maybe we merged too soon. Like the community is saying that we merged too late, right? But somebody would argue that maybe it was too soon, that there was more space for optimization, for work on it. Great example would be work on 3 states right now. So the clients, it's not a hard fork, it's just optimization within the client is a 3-state database. So instead of keeping the beacon state in the disk, it can be in the memory, it can produce blocks much faster. And also connected to this, they are changing the way that archival node works on beacon chain. And it's super funny because it's like 1,000 times smaller now. Before it was storing every state, now it's just storing the diffs, which are literally 1,000 times smaller. So instead of 5 terabytes, you have like a few hundred gigabytes. Yeah, the withdrawals were enabled as the direct proof of stake upgrade, finishing it. And now there is this thing called single slot finality. Now, single slot finality is very interesting, very important, and that's another thing that is considered like wasn't baked properly when the merge happened, or something that still needs a lot more research, basically because we rely on the ghost, on the Gasper mechanism, which is beneficial in a way that, like, even if there is no finality, it can still go on. However, what is progressing, not just these days, is the research on a single slot finality, which would enable us to achieve the finality in the proof of stake setting just after single slot. So it means that you would wait a few seconds instead of minutes for user, but also it can enable us to have more stable network. And the researchers are trying to figure out how to do this without validator bandwidth overhead and so on. And of course, it enables sharding. It enables this data availability sampling idea, which is based on beacon chain sampling different shards. And I'm going to get there with Denkun. And well, one of the important things is that it actually enabled secure light clients, because now the light client can verify the root of the beacon slot, and that way it can be sure that the execution data it's getting are correct. So we have Helios, Kevlar implementations of Lite clients, which are software by itself and can ensure that the data that you are running just in your local small wallet are correct. And upgrade, which is not related to proof of stake and is coming, is Verkle trees. I'm going to talk a little about that, but mostly I wanted to talk about Denkun, which is Deneb and Cancun upgrade, and together it's Denkun. What it introduces, the main feature are blobs or proto-danksharding. So, because what is happening right now is that we have all these layer 2s or rollups on Ethereum, and they are putting all their data in form of call data to the Ethereum state, which is pretty inefficient and like naive way of doing it. The call data is not even intended for storing data like that. So instead, we have this first step towards data availability danksharding. We call it proto-danksharding because of Proto Lambda, who came up with the concept. And this changes the way how the rollups behave, it introduces a new type of transaction. We call it blob carrying transaction. It's like a bike and you have a sidecar. The sidecar is the blob now. So what it does is that it carries a blob, just like piece of data, and instead of storing this data to Ethereum, it stores it on the consensus layer ephemerally, so it disappears after 4 weeks. So there is no like disk overhead for the data, because rollups just need this data to achieve validity after 1 week or so. This ephemeral data are referenced by KZG commitment. So the KZG commitment is there to prove the existence and the structure of this blob of data, and the layer 2 can just reference this commitment, which has a precompile. We don't need to execute anything in EVM. We don't need to do much computation, and it's much more efficient than just using the call data, which would enable rollups or future shards to store this data like 10 times more effectively. So that's nice. A part of that, in Denkun, we are removing self-destruct. That's important. Finally, goodbye to this awful opcode. And transient storage will be enabled, which is a new opcode, a new feature in EVM, which enables efficient handling of data. Uniswap v4 is dependent on this. So the new version of Uniswap will go out as transient storage is enabled on mainnet. Yeah. And yeah, oh, by the way, yeah, so for cryptographers here, you might know that the KZG commitments require structured reference string, which needs to be created by a trusted setup ceremony. So there was actually a huge trusted setup ceremony, the biggest one out there, with more than 100,000 contributors. And a bunch of these contributors were cats. We built this cat toy, which collects entropy from cats, and that's submitted to the KZG ceremony. So now Ethereum, or the Denkun, which dank scales the blob space, will be secured by 20 cats. Yeah, that's the state of Ethereum, my friends, after the merge. Okay, yeah, so that's happening, or we can also call it a surge, as it's called in the roadmap. The layer 2 data flooding the layer 1, and yeah, and it's towards the full data availability sampling, which I don't want to dive into. I wanted to mention the Verkle trees, which is actually like, so after the Denkun, it seems like the next thing which is feasibly upgradable on Ethereum are the Verkle trees, or the vector commitment Merkle trees, which are alternative to the MPT, to the Merkle Patricia tree, in a way that the leaf nodes are connected with vector commitments, and these commitments enable you to generate a witness, which is much more smaller, efficient, and it can be used by stateless client. So we have we can enable stateless clients thanks to Verkle trees, and these are elephants because they like to uproot trees. Yeah, and I wanted to talk a bit more about the roadmap, but I'm running out of time. One of the things that I would mention is the PBS part. There is a lot of research on enshrined PBS and censorship-resistant lists, because with the proposable separation, it became normal that all the validators just listen to some other block builder, and they are just proposing it. So we are enshrining this into the protocol because we are trying to find some nice compromise in this huge, in this scary triangle where Ethereum never wants to satisfy its decentralization. So it's it takes all these crazy ideas that I just talked about to fit somewhere in the triangle. And Yeah, it's an infinite garden, but I believe that it leads to the ossification. Recently, we hear more and more devs talking about ossification of Ethereum in coming future. And yeah, can you imagine it? Ethereum will be done maybe one day. That will make us happy. If you are interested in Ethereum core development, check out the Ethereum Protocol Fellowship. You can ask me about it. And I'm a minute over. That's all, folks. I'm sorry about the rush ending. Thank you so much.
That is some serious bike shedding, yak shaving stuff. I'm really thankful that this is all happening on Ethereum. Is like my first sort of like gut reaction. So there's this argument that we have in Bitcoin is that theoretically anything that works that's developed on other chains will be, can potentially be done on Bitcoin. So if you look at the developments that are happening on level 2s and how we're building EVM chains into certain solutions and also being a very high supporter of the Lightning Network, my question to you would be, what do you potentially see coming out of the roadmap and the development in Ethereum that can end up in the Bitcoin and proof of work ecosystem?
Yeah, that's a great question. Thank you so much. I mean, because I cannot really imagine like these things being directly applied on Bitcoin, just like because of how Bitcoin is conservative and how different the technology is. But it also progresses. There are proposals for rollups, for ZK rollups on Bitcoin, and Jeremy Rubin, Ruben Thompson, Paul Storz doing their sidechain, drive chain, state chains proposals, which are, I believe, very much inspired from discussion on the rollups of Ethereum. But in Ethereum, I mean, I believe that most of the inspiration for Bitcoiners is actually like, this is how not to do it, right? They look at the mistakes, so they know what to avoid. So we are the trailblazers. We mark the path, like this is where it might work, this is where it doesn't work, and then Bitcoin can, or whatever chains can bootstrap like what is the usable, feasible path. Yeah.
So I guess that in Bitcoin we talk about the potential attack surface, and in Ethereum we talk about the argument surface. Would that be
the what surface?
The argument surface.
Argument surface.
Yeah, it seems to me that in Ethereum there's just like there's this huge surface area of all of this development, and there's huge amounts of discussions that go on around it, which have more rapidly productive implementations that happen through approvals of commits than happens in Bitcoin. And it seems that in the proof of stake network, in the Ethereum ecosystem, that there is a much larger surface of argumentation than there is in the proof of work.
Totally. So what I was showing right there, all the forums and the calls and so on, like it's out there in the open. And first of all, like, I mean, what you say, it's overwhelming. There is so much of it. There are all these discussion arguments all over the place around different technical specialties. But it's what I call the Unix philosophy, the modularity. So we have people who are experts who are diving into certain areas, and they're able to craft the best solution in this domain. So there are many domains. All of this discussion is out there in the public, and that's what I find beautiful about the whole open free software ecosystem, where we have this open research where anybody can learn about it and can just come and contribute and be awarded later on, right? So that's definitely there, like for Ethereum, the attack and argument surface, there is definitely more complexity being introduced, but also more people working on it and more people who understand it. What I show there, the protocol fellowship managed to foster like 50 new core devs this year, just this year. So there are many people interested in diving into it, and thanks to like being able to focus on a specific domain and everything being open, it's happening. Yeah.
Do we have a question for Mario? Okay, please.
Hello. Is there anything that can be done on the protocol layer to deal with the LSD centralization problem, apart from switching to proof of work?
Yeah, that's a good question, how we solve the LSD centralization. The LSDs are growing because of people, because of the market, because people choose their token and support their thing. So like one thing which is not like protocol level solution is that people, and we see it in the community of Ethereum, that like people prefer non-censoring relays, they prefer alternative LSDs and more distributed staking pools and so on. On the protocol level, what is happening actually in Dencun, I didn't mention that, there is churn limit being introduced, so the big stakers cannot grow as fast. There is this whole research on the protocol builder separation. So like the idea there is that like even if some part of the, big part of the network is controlled, or like many validators are controlled by an entity which is censoring or something, they cannot really have effect on users. So that's important part of it. And generally like the whole proof of stake enables super easily to build blocks at home. Right now, like there are a bunch of people selling miners here, and it's nice, but it's also highly professionalized. I mean, compared to just like running a thing on my laptop, and there are people just proposing Ethereum blocks from their Raspberry Pis. So, like speaking back to the community part, like that's I think is the most important to actually like why I went into this, why I was excited about the proof of stake transitions, that we can now have my little Raspberry Pi here create a new block on Ethereum, define how it's going to look like. It's my decision, my computer's decision. It's completely up to me how if it's valid, right? So we see community embracing the home staking, and it's very easy and it works. It's like running the node with a little thing on top of it. It's easier than running a Lightning node, I would say, less management at least. So I see this more and more in the community. I hope that it's going to grow. So that's like non-protocol level solution. Yeah.
Cool. One question, and let's make it a short answer because I've got to do a giveaway.
Yeah, I'm sorry.
Okay.
Yeah.
Okay.
If you have 32 ETH.
Do I have 32 ETH?
No, I'm saying you can do that if you have 32 ETH.
Well, so in the natively, just with the client software, you need 32. If you use some pool which doesn't introduce much of an attack vector or is completely trustless, it can be up to what I looked into 8 ETH. But there are new protocols which can do 1 ETH. They are not there for so long, I don't trust them that much, but there is this Diva thing which enables, and it doesn't really make sense with 1 ETH because, I mean, the machine is more expensive than that, or like, I mean, it's, I don't know, 400, 500 bucks for a machine, so like it's not worth it to do it with just 1 ETH, but it's getting lowered. And there is another thing that, which also helps with this, that like the maximum capacity of the validator is being raised. It's not going to be, I mean, it might get raised, not just 32 ETH, but it will be more. So now there's actually less validators in the network, which introduces less attestation overhead. So it helps with the bandwidth requirements for the stakers. And now we are getting to the point where the validator entities are grouping like this, merging like this, which would enable us to actually limit the 32 ETH as well, to have, on the other side, have enable smaller entities as well. So yeah, one day. Yeah, thanks.
Please take the time to pick this man's brain if you have any questions about Ethereum from a Bitcoiner. Please pick this man's brain. He has a huge amount of knowledge. Thank you so much for coming.
Thank you so much, Michael. Thanks for everyone.
Speaking to this audience today, Mara.